All right, guys, this is going to be Objective 2-1. We are going to add and subtract polynomials today. So this should look very similar to what you were doing the other day, because when you add and subtract, you're going to add and subtract things that match, things that look alike, or what we call like terms. So if you're adding, you can, if you wanted to, you can circle, underline, triangle, things that match. Like we're going to add 2x squared with what? What would match with 2x squared? Negative 4x squared, okay? I like to put mine vertically in columns, and I think you're going to like this. Most of the time when I teach this. All right, so I'm going to put mine in columns, and I'm going to kind of organize it as we go. Okay, you don't have to do this. If you would rather underline and circle when we get up and do our problems today, I either want to see you underline, circling, boxing, triangling it all in, or I want to see you do the columns. Okay, one way or another, I want to see you organize it. So I like to organize it so that our answer's in the correct order. How did I tell you the other day that we like our answers to be written? Well, in simplest form, always. Yes, I agree with that. But we want to start with what? Like, do I want to start with the x squared, the x, or just the number? Yeah, I want to start with the highest exponent of the variable. So I see degrees of 2, okay, because that has a, so I'm going to make a column of 2's. I also see degrees of 1, and then I see degrees of 0, meaning just the numbers. Do you understand what I just did? Yes? And we're going to just put the pieces in the correct way. So the 2x squared would go in which column? The 2's, so positive 2x squared. The 5x would go in the 1. The negative 7 would go in the 0. The 3 would go in the 0, and I'm going to put a sign. Notice I put like positive 3 so I know what they are. Okay. The x squared would go in the, so negative 4x squared is going to go in the 2 column, and then 6x would go in the 1 column. Does that make sense? I just kind of organized, and I went ahead and grouped the things that I'm going to add together. Okay. So then when we add them, 2x squared and negative 4x squared is negative 2x squared, okay? 5x and 6x gives me plus 11x, and then negative 7 and 3 give me minus 4. So my final answer would be negative 2x squared plus 11x minus 4. Any questions on how I did that? Like normally I teach this in Algebra 1, and the students that I get in Algebra 2, they still do the columns. Like when we go back and review it, and they're like 10th, 11th, and 12th graders, and they're like, we love those columns, Miss Corns, because it just makes it easy. It organizes it. That way things aren't in the wrong order, and that way we're all doing it the same way. Okay? Now, what do we know about subtraction? In elementary school, a lot of you did, there was a little slogan that you had, okay? We always say that we do not subtract, we add the opposite, or we copy, change, change. Have you heard of that? Copy, change, change? So, would you agree with this statement? How many of you would rather add than subtract? Yeah, we'd rather add, correct? So what we're going to do is we're going to make this an addition problem. And so all we're going to do is we're not going to subtract. We are going to copy, change, change. We're going to change this to addition, and then we're going to change all the signs here. So we're going to copy the first part. So this will be 4x cubed minus 3x squared plus 6x minus 4. We're going to change the subtraction to addition, and then copy, change, and then you got to change all the signs in the second polynomial. Okay, all we're doing, guys, here is I'm giving this negative, I'm just distributing on step 1. You know, mean that -1 that you did yesterday? Everybody agree that's a -1? Yeah. All I'm doing is I'm just going ahead on step 1, and I'm just giving that negative to everything. So when I give this negative to this, it makes it a positive. When I give this negative to the x squared, it becomes a negative. And when I give that negative to the -2, it becomes a positive. Now, it's an addition problem, so you can just make your columns. What do we see degrees of? What are my exponents? We have a 3, we have a 2, we have a 0, we have a 1, and we have a 0. Does that make sense? Everybody understand what the 3, 2, 1, and 0 are? Those are just the exponents of the variables. Okay, so here we go. Let's just organize it. Where are you going to put the 4x cubed? All right, it's going to go in the 3 column, so 4x cubed. Where are you going to put the -3x squared?
Column 2.
Where are you going to put the 6x? Lane 1, column 1. Where are you going to put the -4?
Lane 0.
Lane 0. Okay, how about 2x cubed?
Lane 3.
It goes in the 3. How about the -x squared? What should I put with that -x squared? So I don't mess up.
1.
-1x squared. Put a number with it. Everybody understand it's got a 1 in front of it? Okay, where should I put the 2? What's the exponent of?
Sorry. 4.
It should be in the 0 column, right? So, any questions on how I organized it? And then you're just going to add them. 4x cubed and 2x cubed gives me 6x cubed. Very good. -3x squared and -1x squared gives me
-4x squared.
-4x squared. What do I do with this guy?
You just bring it down.
He doesn't match with anything, so you just bring him down.
Yep.
And then
-2.
-2. So there would be your final answer. Do we like the columns?
Oh, yeah.
I mean, you don't have to lie, but
No.
some people say that's a waste of time and energy, but I think they just look at it and they do this, and they do this, and they just add them. But what happens when you do that?
You get mixed up.
You make mistakes. You get mixed up. Okay? All right. So let's take a look at this. So it wants to know when you work this part out, what will be the missing term over here? So what I would say to do is work the problem. Don't worry about this part over here. You with me? Don't worry about the question. Just let's go ahead and add this stuff together. How do I do 3 things together? Like, what should I do?
You should distribute. No. Copy, change.
Let's copy, change. Where am I going to copy, change? With the first part, second part, or third part? The third part. Wherever you see the subtraction. We don't subtract. We change it to addition, and then we give this negative to everything on the inside, correct? So I'm going to copy all this stuff down. So all this stuff gets copied down. Then I'm going to change this to addition, and then I'm just going to go ahead and give that negative to everything on the inside. So what will that become? -d plus 2. So here's what I would like for you to do. Let's make your columns. I want to see if you can do this. Make your columns. See if you can group all this stuff together and add them together. Okay? I'll give you a second to do that. All right. So we see degrees of 2, 1, and 0. Okay? Where's the 6D go?
60 goes in 1.
In the 1 column. Just like this.
Yeah.
Just like that. what do I do to ensure that I don't miss anything? I put an addition sign in front of it, okay? I put a sign in front of every single number. That way, because if you just get in the habit of just bringing down the number or the term or the variable, you might forget to bring down, like, for example, you might just bring down what on the next part?
Yeah.
You might just bring down 1. Does that make sense? You got to make sure you bring down -1. That can mess you up, okay? So 5d squared goes in the 2 column. Positive. 3d goes in the, so positive 3d. Negative d goes in the 1 column, so that's negative 1d. And then 2 goes in the 0 column. Any questions on that? Okay, notice too, like, as you put them in the column, like I underline them, or you might want to mark them out. That way you make sure you get them. Does that make sense? I work left to right. I don't just pick randomly. Okay, I go to each piece and make sure each piece gets down there. That way you don't forget one. Okay, so what comes down? 5d squared. 6d plus 3d minus 1d.
8D.
Plus 8d. Very good, Eli. Okay, -1 plus 2
Plus 1.
plus 1. So, go back and answer the question for me. What's the missing term?
8D.
8d. Do you understand? Like,
Yeah.
when it gets confusing, like when we first popped it up there, it looked like, oh my goodness, what am I going to do with this? But work the problem and then go back and look at the answer. Okay, don't try to figure this out without doing your work. All right, we're going to do one last one. So this is a perimeter question, and it's good to do these. So how do we find perimeter?
You add all the sides to the shape of the figure.
Okay, we add everything up. So is this any different than what we were doing a minute ago? No, make your columns. What degrees do we see? 1 and 0. Okay, and it's got fractions in there. It's got a half and 3/4, but you have a calculator. So can you add? I'd put parentheses around the fraction and just use your calculator and add them up. Okay, so see what you can do with it. So we see groups of 2, and we see groups of, oops, not degrees of 2. What's Miss Corn's doing? We see degrees of 1, and we see degrees of 0. Okay, so it doesn't matter where you start. Let's start up here. Where's the negative 5x go? In the 1, and then positive 7 goes in the 0. Okay, here we're going to put in what? Plus 1x, and then plus a half. Okay, down here we're going to put in positive 4x and positive 3/4. And then here we're going to put in positive 4x and negative 1/2. Any questions? So in your calculators, if you will put in -5 and hit the plus key, plus 1, plus 4, plus 4, it should give you 4x. Okay, and then let me ask you here, what happens to the positive 1/2 and the negative 1/2?
They just cancel.
They do, and then you just add 7 plus 3/4, which you get 7.75. Did anybody math enter it? So plus 31 over 4. Like so. It's fine, 7 point. So here's a rule of thumb. How did I know that I probably wanted to put it in fraction form?
Because there's fractions in the front.
Because, so if the question has fractions, you want the answers to have fractions. If the question has decimals, then you want the answers to have decimals. If the question doesn't have one or the other and you get a decimal or a fraction, which one do you do?
Decimal. No fraction. No.
I would say in algebra, fraction.
Yeah.
9 times out of 10, I write my answer as a fraction. But I would accept 7.75. I'd accept it. Does that make sense? But, you know, just because this had fractions, I probably want that to have fractions too. Okay? All right. I'm going to do one last one. And I'm going to make this one up. There's something I want to show you. So let me make this one up. All right, here we go. So we don't subtract, we add the opposite, or we copy, change. Okay? So listen to me. Can you copy, change, and put it in the chart at the same time? Yes. No. Like, show me that you're going to copy this. Like, I want to see you rewrite the problem. And I know y'all are like, but I promise you, if you do this, you'll get it right. Okay? I want to see where you change this, and then I want to see where you give the negative to each of those. I want to see you make that a negative, make that a negative, make that a positive. Change all the signs in the second one. Any questions on that? No. Okay? Then we see degrees of
1,
2,
1, 0.
and 0. Okay? So 7x squared goes in the 2. 3x goes in the 1. And then negative 1x squared
Negative 3x
minus 3x
plus 7.
plus 7.
And then it equals 6x
All right.
squared.
So this equals 6x squared. What happens here?
They just add
The question is, what do you, like, some people feel like they need to bring down like an x. But if you bring down an x, that means what?
x.
That means 1. And 3 minus 3 is not 1. Okay? So they cancel out. You don't write anything. Any questions about that? Okay? It makes 0 x's, meaning you have no x's. Okay? And then here, this would be plus 2. So your final answer would be minus 2. Thank you. I get going quick and I make mistakes. Minus 2. So the answer would be 6x squared minus 2. Okay? Any questions on canceling out?
No.
Okay.